So we're now going to look at making conclusions and interpretations and hypothesis tests. That is actually probably the more important part than most of the calculations and such that we've done, is making those conclusions. And so let's look at the conclusion that you can make. All right, so conclusions. If you found something that's unusual, so if your p-value is less than your alpha level, now we know what alpha level is because that's the probability of a type 1 error. So if you know what those are, then you actually would reject HO. So if you found something that's very unusual, again, the rare event rule of probability says, or not probability, rare event rule of statistical inference says that if you're making an assumption and then you actually find something that's very rare and unusual, then you have to assume that assumption is false. So if you have an alpha level and you have a probability that's less than that alpha level, then you actually would then reject what you assumed. And we assumed HO was true. So the conclusion would be you're going to reject HO if your p-value that you calculate, we actually haven't talked about what a p-value is yet, but if your p-value is less than your alpha, then you're going to reject HO. So let's talk about what that p-value is. The p-value is the probability it's just another way to say probability. So p-value is just your probability that you find an X bar less than your calculated value, or an X bar greater than your calculated value, given that HO is true. So you actually already know how to do these calculations. You've been doing them for a while, but this is basically what is a p-value. And so this is going to be from your calculations you're going to do, and you're going to calculate this. And you're going to reject HO if that p-value, that probability value, is less than alpha. In other words, if you found something unusual, then you reject HO. If, however, your p-value is not less than it, then you fail to reject HO. If your p-value is greater than or equal to your alpha. I usually don't include the greater than or equal to, just because it's just greater than. We usually don't catch a time when they're actually equal to each other. All right. So we have this. And so now what I want to do is talk about your interpretation. So your interpretation is what we're going to do next. And to help you with this interpretation, I'm actually going to give you another situation of another hypothesis that we're going to work with. And that first one is that you have you do not have MS. Multiple sclerosis. Okay, so you do not have it. That's your HO. Your HA is that you have MS. All right, so if you reject HO, that means you actually have evidence to show you have MS. That means there is evidence that you have MS. By the way, the test for that is they actually do an MRI of your brain and look to see if you have lesions on your brain. And so if you see lesions on the brain, then you have evidence to show that you probably are getting MS. If you fail to reject HO, that doesn't mean you don't have MS, unfortunately. So as I said, the way they determine if you have MS is they do an MRI of your brain and look to see if there's lesions on your brain. If they see the lesions, then there's evidence that you have MS. If they don't see the lesions, it could mean you don't have MS. Or it could mean the lesions just haven't formed. That you're going to have MS. You have MS, but you just don't have any lesions yet. So the problem is that you don't know. Just because they didn't find any lesions, you don't know if you have MS or not. So all you can say is there's not enough evidence. To show or to support, let's say. Support's a better word. That you have MS. You may not have MS, but we don't have enough evidence one way or the other. So to support that you have it. So unfortunately, that's kind of the way the conclusions go in a hypothesis test. In a hypothesis test, your interpretation is either if you reject HO, there is evidence to support your HA. Whatever your HA is. And I wouldn't write to support HA, I'd write out what HA says. So don't ever say reject HO, there's evidence to support HA. I wouldn't actually say there, I would actually say what HA says. There's evidence to support that you got mail, or there's evidence to support that OJ Simpson was guilty, or there's evidence to support that you have MS, whatever it happens to be, your HA happens to be. If you fail to reject HO, there is not enough evidence to support HA. Again, what we want to prove is HA. That's what we want to do. That's the whole reason we did this, to do is to try to find what HA is true or not true. So if you fail to reject HO, unfortunately, you don't have enough evidence to support it. It may still be true, but you don't know. Just like in the one with the MS, you may still have MS, you just don't know. In the case of a jury trial, when they find somebody not guilty, it does not mean they're innocent. It means there was not enough evidence to support guilt. Guilt would be your HA. So that's how our conclusions and interpretations always go in a hypothesis test. Now let's just finish up that first example we were doing, the battery example. So when we did that, we had our variable. So our random variable, in this case, was the life of a battery. Your parameter is mu, and that's your mean life of your battery. And again, usually it's mean if you've got numbers, mean or median that you could do. If you have words, if your variable is some kind of words that you're counting, then you'd have a parameter, a proportion. So usually we're dealing with mean or proportion right now. There are other parameters we can deal with, but those are the common ones. This is your first step of a hypothesis test. State what these are. You also want to state your hypotheses. So that's going to be the next step, is to state your hypothesis. If you want to, you can use words or you can use the symbols. Our HO was that the mean life of battery is 500 days. If you want to use symbols, you could just say mu equals 500 days. Normally I do my HA first, so I don't know why I wrote HO first there, but my HA was the mean life of the battery is less than 500 days. So again, if you want to use symbols, you can say mu is less than 500. It's also good to state what alpha level is. We picked an alpha level of 0.05 in this case. Because again, that depends on the situation you're dealing with. All right. The next assumption of a hypothesis test is actually to state and check your assumptions. I'm not going to do that right now. The assumptions depend on, let's spell assumptions correctly. The assumptions depend on, these are things that have to be true. Some people like to call them requirements. These are things that have to be true in order for the hypothesis test to be valid. These aren't assumptions of HO or HA. This is just assumptions of what kind of samples did you take? Do you have a normal distribution? All of these different things like that. We're not going to talk about them right now because they depend on what your parameter is you're dealing with and a couple other things about your hypothesis test. So these depend on the hypothesis test you're doing, and they will change depending on what the hypothesis test is you're going through. Right now, we're just trying to get the basic ideas behind them. We're not actually running a hypothesis test just yet. When we do run some, we'll talk about the assumptions in those cases. So that would be your next step. Then your next step is your calculations. So we were calculating our X bar. We calculated that to be 490. We do have our standard deviation was 25. Our N was 35. You are then going to calculate your p-value. And your p-value is the probability that X bar, in this case, is going to be less than. Because our HA is less than. So this is also less than. So this is whatever your whatever direction your HA is. If it's a not equal to, then you have less than and greater than. But if it's a greater than or less than, you use that same symbol here. We have this being our sample mean of 490. And this is given HO is true. Given that mean is in fact 500. So the only reason we have that is so that we can actually draw our normal distribution. And this is going to be part of our assumptions, allows us to draw this normal distribution. And we can put the mean of 500. So that's the only reason we have this given information. We assume this is true, so we know what to put here. Otherwise, HO has no other real purpose besides giving you something to assume. 490 is over here, and we can shade below. And so we actually already calculated this. This is using RStudio. We'll go back and do that again, just to make sure you see how to do this. In RStudio, you are on a normal curve. So we are going to do P norm. My X bar value is 490. My mean is 500. My standard deviation was 25 divided by the square root of N, and was 35. And our lower dot tail is true. And so there's our probability. Like I said, we already did this. I was just making sure you saw how to do it again. We're going to actually do hypothesis tests differently with R a little bit differently after this, but I just wanted to show you for this one example. Again, we're not really doing hypothesis tests just yet. We'll get into those later. And here's our value. So there's our calculations. There's what we have. Make that a bit bigger. And now we can get to our conclusion. Our conclusion this is where you're going to compare this p-value of 0.009 to your alpha level of 0.05. Since our p-value of 0.009 is less than my alpha of 0.05, we will reject HO. That's your conclusion. Now comes the interpretation, because you can't walk into your boss and say, hey, guess what, reject HO. You need to tell them what you found. And so the interpretation is, we have evidence. There is enough evidence. There is evidence that the mean life of the batteries, remember, what does HA say? HA says the mean life of the batteries is less than 500 days. So you now have evidence for that. You now can say, hey, that's what it is. We actually can now say this. We have enough evidence, and you probably should not buy the batteries. And that's basically the basics behind hypothesis testing. Again, we really haven't shown how to do hypothesis tests per se. This is just giving you some ideas of things that are going on in hypothesis testing. In later sections, we'll talk about how to actually do hypothesis testing depending on what parameter you're going to go for and whether or not you want 1 sample or 2 samples.